So in this video, we're going to go through 10 practice final exam questions, going through some of the ideas that you can expect to see on your final exam. You won't see questions just like this or questions similar to these, but you'll see questions that ask about the same ideas. So let's just jump right in with number one. It says, these two box plots display final exam scores for all students in two different sections of the same course. I've got section A and section B. I want to know which of the following statements best describes the similarities and differences between the two sections. On any multiple choice test, it's a good idea to read through all of your choices and see which ones make sense and which ones don't make sense at all. You can narrow down your possibilities there. And you can also get an idea of what's being asked about. Choice A says both sections have the same center, shape, and spread. If I look at these box plots, right in the middle at this line, this is the center, this is the median. So both of these sections have a median or a center of 80. So they do have the same center. A goes on to say they have the same shape. And this is where I have a little bit of an issue with A. I wouldn't say they have the exact same shape. To me, section B looks a little bit skewed left, maybe because its tail on the left, its whisker on the left is a little bit longer than its whisker on the right. Section A, both whiskers look to be about the same length. But what really gets me in A is the spread. Now, there were two ways to measure spread, and we saw problems like this back in chapter 3. You could use the standard deviation if you had symmetric data, or you could use the IQR if you had skewed data. Box plots give us the IQR. Recall that the IQR is Q3, which is where the box ends, minus Q1, which is where the box begins. So section A appears to have a spread or an IQR of 120 minus 40. Its IQR, its spread would be about 80. Whereas with section B, its Q3 is 100. Its Q1 appears to be about 55. 100 minus 55 is 45. So they don't have the same spread. B is the correct answer. They have the same center, it's 80. Approximately the same shape. That's not exactly the same. Like we said, section B appears to be a little bit skewed left. But section A has a greater spread. It was 80 compared to 45. C is out because it says B has a greater spread. We know that's not the case. A has the greater spread. And D is out because they don't have the same spread. B is the correct answer. 2 also comes from chapter 3. For which of the following data sets is the median a better measure than the mean? Which of these is the median preferred over the mean? We use the mean when we have an approximately symmetric set of data. We use the median when we have a skewed data set. So I'm really saying, well, which of these is skewed? In A, 10 is in the middle. It would be my center. And it is approximately symmetric. In fact, it's perfectly symmetric. It decreases by 2, going down from 10 to 8 to 6, 6 to 4, 4 to 2. We went down by 2 every time. And it increases by 2. So it did the same thing on the left-hand side and the right-hand side. It's symmetric. Here, the mean would be the preferred measure of center. On B, 16 is in the middle. And this data set is skewed to the right. The left-hand side is fairly clustered together. 1, 2, 4, and 8. These are clustered together compared to 32 to 64 to 120 to 256. This is very spaced out. We're skewing to the right because we're making these large jumps in our data on the right. B would use the median as the measure of center. C and D are also perfectly symmetric, just like A was. On C, you've got 1 in the middle. You went up by 0, up by 0, up by 0. You went down by 0 on the left as well. On D, 0 is in the middle. On the right-hand side, you went up by 1 every time. On the left-hand side, you went down by 1 every time. Number 3, for the following data set, calculate the mean and the median. We saw this in chapter 3. To find the mean and median, our most efficient way is going to be to use our calculator. I first off need to get this data into the calculator, so I hit Stat, Edit, and I'll enter these numbers into L1. Remember, if you have old data in your calculator, you just hit Up, Clear, and Enter. All my data pieces are now in. I can hit Stat. I go over to Calc, and I want one var stats, statistics for one variable. When I hit Enter, I can see X bar, my mean is 7.2. And if I can scroll down, my median is 7.5. And that matches choice C. The median is 7.5. The mean is 7.2. Similar idea on number 4, which pair of states have data with different means but the same standard deviation? So Colorado, Nebraska, Colorado and Wyoming, or Nebraska and Wyoming. So I can calculate the mean and standard deviation for each state and compare. So I'm going to get this data in. I go to Stat Edit. To get this old data out, I hit Up, Clear, and Enter. Just entering the Colorado data in. Go to Stats, Calc, one bar stats. So for Colorado, my mean is 23.2. And my standard deviation would be 8.983. I'll do the same thing for Nebraska next. Stat Edit, Up, Clear, and Enter. Deletes that data but keeps it L1. So it's 7, 12, 15, 22, 30. I go to Stat, Calc, one bar stats once again. My mean, my X bar for Nebraska is 17.2. My standard deviation is 8.983. And I don't even have to go to Wyoming. You can see the answer is choice A. Colorado and Nebraska have different means. One was 23.2, the other was 17.2, but they have the exact same standard deviation. On number 5 here, just to save some time because I've read ahead, the correlation or the R between a respondent's years of education and his or her spouse's years of education is R equals 0.70. Which of the following statements is true? If I look at A, B, and C, each starts with a percentage, 30%, 49%, or 70%. Then the rest is the same. So I need to decide, well, is it 30, 49, or 70%? A says 30% of the variance in spouse's years of education can be explained by the respondent's years of education. Well, this exact phrasing, or very close to this phrasing, is what we saw for R squared, which was the coefficient of determination. That was our explanation. It was blank percent of the variation in the Y, which is the spouse's years of education, can be explained by the X, which is the respondent's years of education. Recall that this is the X, this is the Y. I have R. To find R squared, I just take 0.70 times 0.70, or you could say 0.70 squared in your calculator, and you get 0.49. So my R squared should be 49%. 49% of the variation in spouse's years of education can be explained by the respondent's years of education. Whenever you want to explain something, especially the variation or the variance from a scatter plot, you want to go to your R squared value. This was from chapter 4, as is number 6, 7, and 8 here. All from this situation, looking at a person's years of education as the X variable, their annual income as the Y variable. So we can see there's a positive trend here. As your years of education increases, so does your annual income. Number 6 says the least squares regression line is shown in the scatter plot above. What is the most accurate interpretation of the slope of this least squares regression line? Well, here's the slope. It's 5.987. I want to explain what this means. We said our slope is how much we predict the Y to increase by as the X goes up by 1. So I expect the Y, which is annual income in thousands of dollars, to go up by 5.987. So I would take this 5.987, multiply that by 1,000 because this is in thousands of dollars, and that's going to give me 5,987. So I'm saying I would expect your annual income to go up by $5,987 as your X, or your years of education, goes up by 1. And that's always been our interpretation of slope, is how much the Y should go up by as the X goes up by 1. A says for every 1 year of additional education, so as your X goes up by 1, that's correct, you can expect about a $1,000 increase. Well, that's not the case. We expect about 6,000, 5,987, so it's not A. B says for every 1 year of additional education, you can expect about a $6,000 increase in annual income. That is correct. As the X is going up by 1, your years of education, your Y, your annual income should go up by about $6,000. C is out because it says every 6 years of additional education, this is your X, this is going up by 6. You want it to go up by 1. It doesn't take into account the $6,000 increase. It's only 1,000 again. Similarly with D. Number 7 is related. If researchers wanted to predict the income using years of education, what is the response variable or the dependent variable? Recall that this was our explanatory variable on the bottom. Our response was over here, the annual income. So I would expect annual income to be my response. I would expect on number 8, the years of education to be my predictor or independent variable. This bottom could be our explanatory, could be our independent, or it could be our predictor variable. Along this y-axis, that could be your response variable, your dependent variable, or your predicted variable. Those were terms that we discussed in chapter 4. Last 2 questions of this video, number 9 and 10, come from this two-way table. It says, researchers conducted a medical study to find out if treating a sinus infection with an antibiotic reduced the length of the sinus infection. The study included 241 patients who were diagnosed with a sinus infection. There were 113 patients randomly assigned to receive the antibiotic. The remaining patients received sugar pills. The patients were contacted regularly to find out when each patient stopped having sinus infection symptoms, and the results are in this table below. I want to know which treatment, sugar pill or antibiotic, was more likely, had the higher probability to result in a length of sinus infection less than 10 days. So what should help your sinus infection last less than 10 days? What does the data show? Was it the sugar pill, the antibiotic, or were they both equally likely to result in a length of less than 10 days? Well, if you look at the raw data, 80 people who took the sugar pill had an infection of less than 10 days, and 80 people who took the antibiotic had an infection of less than 80 days. So right off the bat, it looks like they're equal, and that C is viable, but that's not the case. We saw two-way tables like this first off in Chapter 2, and we discussed that we never compare the raw data. Instead, we want to compare the percentages. What percent of people who took the sugar pill had an infection of less than 10 days, and what percentage of people who took the antibiotic had an infection of less than 10 days? So for the sugar pill, you would take 80 and divide by 128. For the antibiotic, you would take 80 and divide by 113. Because 128 people took the sugar pill, 113 people took the antibiotic. So 80 out of 128 compared to 80 out of 113. You want to see which one is more likely, which one is higher. If you divide these out, you will see the antibiotic was more likely to result in a sinus infection of less than 10 days. D says, what is the probability that a sinus infection lasted less than 10 days for any patient? Doesn't matter if they were on the antibiotic or the sugar pill. Well, there were a total of 160 people who had an infection of less than 10 days out of 241 altogether. That matches choice